Okay, so another question that we get a lot of times is, I think I have a harmonics problem. Can you help me identify if I have a harmonics problem? And what we typically would say is, what makes you think that you have a harmonics problem? Because there's a lot of things that can happen on a power system that are power quality related that aren't necessarily harmonics problems. So we like to go in and think about the symptoms of the problem to try to clearly identify, if the problem is truly harmonics related or not. Now, what if we had a transient problem? A transient problem could be like a lightning strike or, some other surge event, and typically things blow up. That would be unrelated to harmonics, but you may have a harmonic resonant problem that blows up capacitors, so it may be related. So again, different ways of looking at similar things. Voltage sags are a very common problem. If your equipment is dropping out, it's likely a voltage sag or an interruption or recloser event, but that doesn't necessarily mean that you have, that you don't have something that could be related to harmonics as well, because there's operation of equipment that can occur with some pieces of equipment around harmonic voltage distortion and so forth. So as we look at this, again, identifying the symptoms is super important. As you look at the picture here, the transformer on the right shows, that's an infrascan of a transformer. It shows very high current distortion, very high heating. So if I have long-term overheating, then I likely could have harmonics issues. If I have intermittent operation, things that don't work correctly, as I mentioned earlier, PLCs locking up, I could have a harmonics issue. If I have insulation deterioration, and what we like to say here is, what if you had a transformer and you were identifying whether it's a harmonics issue or a transients issue? If I looked at the insulation on it, and the insulation looked like it was baked in the oven for 3 weeks or a year, that's probably a harmonics issue. If I have a single pinpoint failure on a pretty new looking varnish, that's probably a transients problem. So as we look at that, it's important to know. Audible noise is an interesting one. A lot of times we get audible noise, and electrical equipment really isn't supposed to make noise, but if you've ever energized a transformer and you hear that dong kind of tuning fork sound, that's basically harmonics, second, third, fourth harmonics. It's a short-term thing, but it's actually harmonics, and the kinds of noises that you hear on equipment may or may not give you an indication of harmonic issues. And then finally, with resonance, it's super important to understand really how resonance plays into harmonics, and especially as we add power factor correction capacitors. Now, what we did was we put a couple case study examples here, and we have plenty of videos and discussions on these examples, but I'll just quickly go through and tell you why these particular cases showed symptoms of harmonics. In the first one, there was significant voltage notching, and the welds on the minivan tailgates were not substantial. They were, instead of being 20 cycles long, 20 electrical cycles, they were 8 cycles. And they had to recall on those welds because they were poor welds. In the data center, we couldn't parallel a couple generators. One was loaded and one was unloaded. Because of harmonic voltage distortion, we had issues with the transfer switch and the relay scheme that was used in doing the paralleling. With the steel mill example, there was actually a 30 megavar capacitor bank, and about a third of that, or 10 megavar, failed because of harmonic resonance. And then in the commercial building, as they added more and more fluorescent lights to their building, it turned out that the fluorescent lights were self-infecting and caused those lights to flicker. So then you stop in the middle and you say, the symptom's telling me I have a harmonics issue. What do I do? Do I filter the harmonics, or do I go back and rip out all the lights and make better lights in this situation? So again, just a couple examples of things that show symptoms of actual harmonic issues. So what do I do to identify if I do have a problem? The first step is really to measure the voltage and current. Look for notching, look for significant harmonic currents, and then record correlations between the symptoms of issues that you're seeing and the actual waveforms. As I look and I kind of look at the nonlinear loads that are causing the harmonics problems on my system, if I can correlate that, it's a huge benefit to me to see those waveforms. A lot of times people will just say, I think I have a harmonics issue, but have nothing in terms of waveforms or measurements to back up the case of why they think they do. If I have excessive current in terms of harmonics, make sure you're looking at actual amps and not just percent THD. We have a couple other FAQs that talk about percent THD versus actual amps, and it's important to recognize that you can have a lot of distortion as a percentage, but the actual amps are what get you in trouble. If I'm running on my generator, does it make the problem worse? That's another thing to think about. And then finally, making again that direct correlation between my harmonic sources, my nonlinear loads, and the problem that I'm supposedly having is really going to help you identify if you truly have a harmonics problem.